Okay, so then finally we want, got to go back here somewhere, hypothesis testing for the difference of two proportions, uh, or whether those two proportions are equal. And again, I'm going to stick with this basketball example I used for the confidence interval. Um, Actually, amazingly, I'm not a big basketball fan, but it just seemed like an easy way to go. Okay, so I'm going to go back here. So this is still section 3.2, difference of two proportions, but now we're doing a test of hypothesis. And again, it's probably simple to go with a before and after. But as I mentioned before, as we look at this research question, so there I've got my calculations for those two proportions, is whether practice impacted the team. So another way to say it, instead of just those proportions that way, is does it matter sort of which column I'm in as far as my prediction of success? Okay? And it looks like it probably does, in that, again, we calculated, we got 0.64 for probability of success for the before column, 0.78 for the after column. So now my intuition is that it matters. Okay, but we're going to find out, I think, that we're wrong, statistically speaking. And the reason I think we're going to find out we're wrong is on the confidence interval, 0 was inside the confidence interval, which meant, that if we stick with the alpha equal 0.05, we want to be right 95% of the time. In order to be right 95% of the time, one of the options was there was no difference in the populations that produced those proportions. Okay, so not that those two proportions are the same, but that they could have come from the same population, and so there really was no impact if that's the case. If they truly did come from the same population, so that was a possibility within that 95% confidence interval. And so I'm guessing we're going to get a p-value bigger than 0.05. Now, so the test of hypothesis here is H0, that we can either write it as P1 equals P2, or we could write it as P1 minus P2 equals 0. And then the alternate is that P1 is not equal to P2, or another way to put it is P1 minus P2 is not equal to 0. And so we have those two hypotheses. But again, what I want to point out is, thinking about these columns or rows, and it turns out it doesn't matter whether we think about the columns or rows. My null hypothesis, when I say those two proportions are equal, is that well, if the 32 over 50 came from the same population as the 39 over 50, well, then so did the 18 over 50 and the 11 over 50. And so my null hypothesis is that the relative frequencies or proportions in every column are the same. And then the alternate, okay, so the relative frequencies in every column are the same. Well, let me be a little more clear, as every other column. Okay, it's saying the columns are basically all the same in terms of relative frequency. And then the alternate is at least one column is different. So it doesn't mean that everything's like 50-50 or something like that. It means that if, one column had successes and failures of, say, 70% and 30% respectively, then the other columns do too. Okay? At least one column is different. And so those are really saying the same thing as those two. Okay? Now, so as far as the book, to check this, once again, we need to calculate a z from the standard normal distribution, and we calculate that by taking p1 hat minus p2 hat and dividing that by the standard error. And so that we can get the number of standard errors. Oops, forgot my hat up there. And so, again, it's all about calculating that standard error and, and then looking at our probability in the z-table. And so I mentioned it in the previous video on confidence intervals. There are a couple ways to calculate that standard error. And I guess, so the way it's being calculated, I think the way it's being calculated in, well, let's just go look at it real quick. Well, that's the confidence interval, so I'll get rid of that. Two proportions here. I really should say difference of two proportions. Let me go down here and find the standard error. Okay. Yeah, this is the pooled standard error for this. So I guess for the confidence interval, for whatever reason, I had done the separate standard errors, and here's the pooled standard error. So what you're seeing is that I'm taking all the successes over all the trials. So let me go back here. And yeah, so what we're doing is we're taking all the successes in both before and after, and dividing that by n1 plus n2, all the failures, all the trials, and then multiplying that by 1 minus that, so 1 minus S1 plus S2 over N1 plus N2. Okay, and then that is times, I ran out of room here, so times, so that keeps going, how about that? Okay, it goes down here, times, well, what I want to do is take this over N1, so you'll see 1 over N1 plus 1 over N2. Okay, so what it's doing is it's still doing that idea of P times 1 minus P over N and taking that square root, but it factored out the P because we're saying those are one and the same. So kind of reducing all that stuff up there, we have a P pooled times 1 minus P pooled. So we get that from taking all the successes divided by all the trials. And we're dividing that by N1. And then we're also taking P pooled, 1 minus P pooled, and dividing that by N2. So that's where this, under the square root sign, if I factor out those two things, I'm left with 1 plus N1 plus, or 1 over N1 plus 1 over N2. And so that's what we're doing for that standard error, and we can calculate a normal distribution value from that. Well, again, let's go to Desmos to actually do that calculation. And so we had, I need to change the successes. What was that, 32 or 34? 32. 32 and 18, and change this to 50, and there's our 0.64, and then we had 39 and 11 for a total of 50. And there's our 0.78. There's our difference of 0.14. There is our 2 times the standard, well, 2 times our probability. I don't know where I calculate the probability. Oh, maybe, no, that's the pooled estimate. I don't know, I've got it hidden down here somewhere, I guess. Oh yeah, there's probability, and it's, there's the calculation. So here's the p-value, and it is 0.1229. So it says we have a 12% chance of getting these data if the 2 populations really are the same. The before and after populations are the same. Okay. So the research question is, whether there was evidence for the practice impacting the team, and unfortunately p-value was 0.122 or something like that, which is greater than 0.05. So we fail to reject H0, and that H0 was that P1 equals P2. So we fail to reject that, and therefore we don't have evidence to say the practice impacted the team. It looks like it might have, so maybe we just need more data. But right now, because we failed to reject the null hypothesis because of our p-value 0.122, we don't have evidence to say that practice did anything. So statistically, we could have come up with these 2 different columns, very different looking columns, I think, with the 0.64 and the 0.78, but we could have come up with that by chance from the same population. And there you go, okay? So we failed to reject it. We used our templates, and we got some answers there. Okay, so we'll say that one's done.